Okay, just a second, sir. Yeah, I'm unmuting you, sir.
Okay,
Okay,
1 second.
let me stop sharing. Yes, sir. In the meantime, participants, if you could just introduce yourself in the chat box and let me know what all you're looking forward from this masterclass. So, if you could do that, this will give us a very good idea about the kind of questions we should be. I'll post Ganesh. I will post the LinkedIn page URL in a short while once Vinod Kakde sir starts the session. In the meantime, if you could just introduce yourself, what you are doing. If you're already working in the semiconductor industry, please let us know your profile. And if you have any particular question, do let us know. We'll be very happy to take that up towards the end of the session. Okay, so Balakumar is from ELK Education. Vinod sir, are you sharing the screen, please?
Yes, I'm ready to share now.
Please share, sir. Yeah.
Are you able to see?
Not yet, sir. Okay, Parvati, you're doing research. Okay, Sudha, you see, damn. Okay. Logic Fruit Technology, Jai Krishna. Okay, nice to have you here. Dr. Mayur. Okay, Pimpri Chinchwad University. Welcome, Dr. Mayur.
Once again,
Thank you, Madhukarji. I'm sorry for that name. I changed it, but somehow not able to see it now. Really, sincere apologies. Bhuvnesh, yes. Jerin, Don Bosco Group of Education. Okay. SMT in. Okay. Okay. Durgam. Okay. AMD. That's good. We looking forward to. And somebody is from Railways also. Okay. Geetesh Gupta. Okay. Analog Layout Engineer. Okay. Very nice. Arvind, this person. Sir, are you, is there some issue you're facing, Vinod sir?
Yes, I'm facing a challenge. I'm not able to share it. I don't know.
Okay, okay. Let me make you a host. Let me see if you're able to do that. Let me see. Let me just uh, uh, I'm making you host, sir. Please see if you're able to
Okay.
are you able to do this right now?
You are the host now. Okay. Share. Is it coming now?
Not yet, sir. Not yet, sir. Or should I start? Should I run the PPT?
That would be better. You can start. I will start giving my comments.
Okay, sir. Okay. You may please go ahead, sir. Right.
Yes. Yeah.
Okay, so before you start, sir, let me just share. So we'll be taking the Q&As after the session is complete. If you have queries, please type in the chat. We'll take them up at appropriate intervals. There will be a bio break at 8:30 p.m. for 5 minutes, and I would request you to switch on your cameras at the end of the session for conclusion. So, sir, please go ahead. Is everybody able to see the screen? Please, okay, please go ahead, sir. Let me know when you want the slide transitions to happen. I'll do that.
Sure. Thank you, Sumit. Good evening, everyone. Thank you for giving me this opportunity to represent my organization and present before August audience about the Indian Semiconductor Mission and what the scheme plans to do for the future. So I start with the Indian Semiconductor Mission. This is a strategic initiative which was launched by Government of India in December 2021 under the Ministry of MIT and promoted by Niti Aayog to establish India on a global hub for semiconductor display manufacturing and design. Basically, it aims at reducing the dependence on imported semiconductor, which accounts for about say 65 to 70% of total India's electronic component import. Next slide. Next. Yes. So we look at what is the global semiconductor landscape, and then we will look into how India is progressing on that front. So typically, the global market size, as measured in 2020, is approximately 600 billion, which is now 697 billion in 2025, and which is projected to reach US$ 1 trillion by 2030. Uh, the majorly the growth is driven by upcoming technologies such as AI, 5G, automotive, IoT, quantum computing, advanced computing, edge computing. So these are the leading technologies which are driving the growth of semiconductor industry globally. And also there are a lot of efforts put up by global bodies such as US Chips Act, which has contributed close to $52 billion, EU Chips Act, Euro 43 billion, Japan, Korea investments, and also India is also investing heavily in this. And you would be glad to know that hello, can you see it now? Yeah. So
Yes, sir, we can see. Please continue.
yes. So Indian government has increased the budget for ISM 2.0. It will be close to 1.25 lakh crores now, from 76,000 crores. So it's we are going in the right direction, and it is also needed for supply chain resilience and geographic diversification. That is the global landscape of semiconductor industry. Next slide, please. So Futurum Research has published this report from which we have taken this snapshot as to how semiconductor companies globally are grabbing the market share. This is 2024. The market has risen to close to $697 billion. And you can see all the top-notch companies. They are there. They have acquired almost 7% of the total market, with Nvidia topping the list, close to 16% of market share. You have all the big players such as Samsung, Intel, MediaTek, AMC, Micron, Qualcomm, all the top-notch companies, top 10 companies, they represent almost 70% of the market share. Next slide. Yes. So this is again one graph we had taken from one of the published media reports, in which the companies they represent. These are top. One second. Yeah, if you break down the data, revenue versus the year for the top 20 companies with equal proportion per segment. So we have divided it into the 5 major segments such as equipment manufacturing, fabless, IP, for manufacturing, IDM, packaging, assembly. So if you look at year-wise, the breakdown is given and how much revenue the top companies are earning, you can see. Also, the similar breakdown in terms of year, what is the net income of the top companies with respect to the segments is also broken. That is the year-wise. Both the years are compared, and you can see that how companies are performing. And in the graph too, you will see that fabless IP is where the company is focusing a lot. Their focus is on the outsourcing. Uh, design market and semiconductor chips, and they are also outsourcing. Next slide. Yes, again, this is a McKinsey report. And McKinsey has tabulated what are the key technologies which are shaping the semiconductor industry. You can see that they have broadly classified this into three buckets: the advanced packaging, advanced material, and AI-enabled manufacturing and design. So you can see that AI is basically driving the growth of future technologies, and also it is fueling the growth for semiconductor industry as well. And on the left hand side, you will see the overall growth in global semiconductor market, which is driven by the technologies like automotive, data storage, and wireless industries. And it is projected that compared to 2021, in 2030, you will have almost 7% CAGR with all the segments growing. And the maximum growth will be seen in computing and data storage, followed by wireless communication, automotive electronics, industrial electronics, consumer electronics, wired communication. These all segments will fuel the growth for semiconductor industry in coming years. And the growth contribution per vertical, you can see, is in the range of approximately 30%. Next slide. Yes, this is again a snapshot by McKinsey and Co. In which you can see that how AI and machine learning skills have they have been replacing the system architecture knowledge on the European job market, and also the worldwide how they are performing. So if you see the segments such as memory, fabless semiconductor, microprocessing unit, capital equipment, foundry, you will see that top-notch companies take place in the top league. So in the memory, you will see Micron, Samsung, SK Hynix, Western Digital acquiring almost 95% market share. Similarly, in the fabless semiconductor, you will see Apple, Broadcom, Nvidia, Qualcomm, followed by Intel, and all the leading companies you will see they are performing heavily. And if you look at the right hand side graph, you will see that what are the technologies which are shaping. So you have systems architecture, SoC, SOP, complex ASIC design, data analysis. So this graph shows it compares the 2 year 2020 and 2022, and you will see that how the top skills are replacing. So you will see top three skills which were systems architecture, data analysis, and AI and machine learning. So you see that number 3 is taking the first place now. AI and machine learning is superseding the other things which are required. Knowledge applications, outlay, reliability, hardware, software, security, knowledge at new material, analog design. So you will see that the top position which was acquired in 2020 are replaced by AI, machine learning, and knowledge is taking the precedence over the traditional skills. Next slide. Yes. So this is the where we stand. About 70% of growth is predicted to be driven by just three industries: automotive, computation, data storage, and wireless. So you can see that as per the Society of Automotive Engineers, level 4 car with an electric drive train could be about $4,000 as compared to 500 for an SEI level 1 car powered by the IC engine. So you see there is a change of shift here now. The traditional IC engine being replaced by electric drive. So everything is now electric driven actually. So you see that even in the automotive sector, semiconductor industry is fueling the growth for new electric vehicle now. Next slide. So this is the forecast for the talent which is required by 2030. This is a European snapshot. You see in 2021, almost 200K were the number of professionals working in the semiconductor industry in Europe. And the projection is by 2030, this will be 3 times of what the working professional is. So you have a talent gap of almost 350K, and it is estimated that talent by 2030, 120K would be supplied, and so there will still be a gap of 350K, 350,000 professionals in European Union. So that is, so you can see that huge employment generation will be fueled by semiconductor growth. Next slide. So let's talk of the Indian, what India is doing in semiconductor industry, how the growth is fueling. So as I have already told, India's semiconductor mission in 2021 with an outlay of 76,000 crore incentive. And of these incentive, close to, this was broken into 3 parts actually. I will tell you the breakup, how the breakup was there. So with a budgetary support of 76,000 crore, 65,000 crore was for chip manufacturing and packaging unit. 10,000 crore was outlaid for modernizing the semiconductor lab at Mohali, and 1,000 crore was for design linked incentive scheme. Okay, so what was the aim actually? The aim was to establish fabrication units, packaging units, and design ecosystem, and to build a vibrant ecosystem around the semiconductor industry, reduce import dependency, promotion and innovation with related technologies, increase the global competitiveness of India, job creation in this field, and skill development. So the global competitiveness, this will position India as a key player in the global semiconductor market, which is supposed to reach, it is projected to reach $1 trillion by 2030, and India aims to achieve at least 10% of the total market share. Also on the skill development front, India needs to develop a skilled workforce targeting close to 85,000 engineers and technicians across 113 academic institutions. Next slide. Yes, so look at what are the major investments and projects in India which are attracted by ISM, Indian Semiconductor Mission. The mission has attracted investments worth over $1.5 trillion. That is a major achievement, and the key investments have been 2.75 billion ATMP plant at Sanand, Gujarat. Tata Electronics has invested close to $11 billion, which is for a proposed fabrication plant in Dholera, Gujarat. ISMC Analog has put up a proposal of $3 billion in Karnataka. CG Power and others under DLI scheme for design innovation. HCL and Foxconn, they have joint ventured for a 3,700 crore facility in Jewar to produce display driver chips with a capacity of 36 million units monthly. So these are some of the snapshots of the ISM scheme which is being launched. Next slide. Yes. So now in the ministry, the discussion is going on the second phase of ISM. The second phase of India Semiconductor Mission is expected to have a fresh budgetary allocation of 15 billion. From 10 billion, we are going up to $15 billion, approximately 1.25 lakh crores. This follows the initial phase, which was 76,000 crore outlay. The second phase will focus on strengthening the semiconductor ecosystem, support for raw materials, equipments, and specialty chemicals which are used in the manufacturing. Also, the government of India plans to provide additional support for gases and other elements which are essential for semiconductor production. And on the similar lines, a $10 billion project by Tower Semiconductor in conjunction with Adani for a chip manufacturing unit in Maharashtra is also proposed under the second phase of ISM. Next slide. Next, please. Yes. So now you see on the skill development on the employment front, India holds close to 20% of the global chip design workforce, according to ISA, and 50,000 engineers are working in the semiconductor design in India, which is estimated to reach 250,000 by 2030. And you see the emerging roles are process engineers, packaging specialist, reliability analyst. Also, there is huge requirement in the foundry and the semiconductor welders. It's a specialty skill, and you will see that a lot of job market will be created in those specialized areas by the growth of semiconductor industry. Next slide. Next, please. Yes. So let's see at the India's global positioning by 2030. Currently, our share is less than 1% in the global semiconductor manufacturing, and by 2030, we plan to close to 10% of the market share. This will be achieved by focusing on design, packaging, and specialty fabs. Also in the domestic market, which is supposed to reach, which has already reached $500 billion by the end of 2025, and this will be fueled by academic and R&D partnership. Already, you will see that ANRF, Anusandhan National Research Foundation, which is a flagship program under the Ministry of Science and Technology, is promoting research and development ecosystem, and in which semiconductor is also acquiring a huge space now. So in the coming years, you will see a lot of R&D institutes putting up research and fabrication around the semiconductor industry. Next slide. Key takeaways from my presentation: India is investing heavily to become a semiconductor powerhouse. This will be achieved by global realignments favoring India's talent and design base, which will create massive demand projected for the skilled semiconductor professionals. And our program, which is a 100-hour program, also aligns with this transformation. Next slide. So let's see what is the global shift which is creating opportunity for India. Geopolitical shifts drive decentralization away from East. The focus, which was on the China, Taiwan, and South Korea, is now slowly shifting towards India. And India is definitely benefiting from China plus one strategy, where every country is looking for an alternative to China, and in which India sees a prospective global opportunity in becoming a semiconductor hub in coming years. 75% of the global semiconductor firms have India R&D presence, which are very heartening news. This comprises of outsourcing of design, testing, system modeling. These are the in the growth phase in India. And as I've already told that the job market would be close to 250,000 plus skilled engineers and analyst job by 2030. Next slide. So yes, so you'll see rising roles not only in the uh, design and verification. You will have a lot of opportunities in ATMP and reliability testing, DFT, ESL modeling, signal integrity, system integration, power packaging. So you will see a big ecosystem developed across semiconductor industry, and new type of jobs and new skills would be required for meeting the needs of semiconductor industry. And you will see that a lot of collaboration between the industry and academia to fill the skill gaps, such as ANRF, Science and Technology Department, ISM, and also Niti Aayog on the policy front is pushing for new initiatives and new collaboration with industry, academia, and the corporates. Right. Next slide. Next slide. Yes. So, what is the future outlook which is holding for the semiconductor industry? The ISM is poised to transfer India's semiconductor landscape through increased budget allocation. It is proposed India Semiconductor Research Center, which will focus on niche technologies such as quantum computing and 5G wireless technologies. Government's proactive policies combined with private investment from companies such as Tata, Micron, and Foxconn, and international collaboration will position India to achieve significant milestones, such as rolling out its first chip by September 2025. So you will see that India will roll out its first 3 months, and we will have our first fab to be operationalized by 2026. And India is set to generate an impressive 800K to almost 1 million jobs in semiconductor industry over the next 5 years. So this is very promising future outlook, which is presented by ISM in coming years. Next slide. Next.
You come to a conclusion, sir. Thank you, Vinod, sir,
Yes.
for your session. Hello.
Yes, please.
Yes.
Yeah,
Yes.
please go ahead.
Yes. Thank you, Vinod, sir, for this quick take on opportunity shaping up India's semiconductor growth story. I have a question for you, sir, before we conclude your session. Sir, is there a plan for
Yes.
plan for test houses or setups for industry under ISM?
Yes, this will be covered in ISM phase 2, which is under consideration. So we have definitely plans for that. And Niti Aayog is making policies for that. So definitely it will be there.
Okay. Thank you so much, Vinod, sir, for your insights.